My name is Craig. I'm a security researcher with the Tripwire Vert Group. I write vuln content for our IP360 scanner, and I also do a lot of vulnerability research on my free time and at work. But today I'm actually going to be talking to you not about vulnerabilities, but rather about how to work with some of the tools that are out there for RFID hacking. So I've accumulated with Vert a number of tools for working with high frequency and low frequency RFID. And I've noticed that there's not really a lot of consistent documentation out there for some of these tools. People release patches for adding new functionality for various things, but it doesn't often get a lot of documentation for it. I mean, you can definitely read through the source code and figure things out, but I wanted to make things easier for people. And then I also wanted to look at ways that I could use the 3D printer that we have to try and enhance some of the practical attacks that you have with RFID tools, and also look at some of the different options that you have or opportunities for research through that. So what we're going to go through here, I'm going to overview the tools that I'm working with for this project, go through some of the basics of how RFID functions, some of the basics of how 3D printing functions, and then we'll get into firmware changes that I've made to the Proxmark 3 and how these changes were made. This is actually documented in a lot more detail in a white paper that's going to be available on the DEF CON site. And then we'll get into the 3D printing stuff and look at how you can make antennas and how you can conceal different tools with 3D printed objects. So these are the tools that we have going on for this. You've got the RFID tools over here. The Proxmark 3 is kind of your Swiss Army knife for all things RFID in the low frequency and high frequency bands at least. I've got below that the PN533 USB stick. That's an NXP chipset on a USB stick. And finally on the bottom there is the RFiddler V22 board, which I obtained at DEF CON last year. Moving over to the embedded computing tools, we have the USB Armory, which is a little thumbstick sized computer, and also a Raspberry Pi board that I was looking at. Finally, for the 3D printing, I was using primarily a Cube Pro 3D printer, which we acquired in the office. So getting right into it, the Proxmark 3, for anybody who doesn't know, this is a board that was developed as part of a PhD thesis by someone who was analyzing the transit cards in their city. As I said, it does low frequency and high frequency support. And at the heart of it, you've got a Xilinx Spartan 2 FPGA. This is what's used for doing the precise timings that are needed to do effective NFC communication or high frequency RFID communication. It also is providing a SPI interface and an SSP interface for transferring data and commands. The heart of that is the Atmel microcontroller, so something very similar to what you might find on an Arduino board. This is actually what's handling the communication from the computer and relaying commands over to the FPGA as needed and doing demodulation and decoding. Most of the heavy lifting actually does happen in C code in there, so you don't really have to worry so much about the Verilog that goes on in the FPGA unless you really want to do some low-level stuff with changing around the NFC modulations. You've got a 8-bit ADC on there, an analog to digital converter, which gives you a 40 megasample per second bitrate on there, and it receives its commands over a SPI interface. The connectors on the board, you've got mini USB that you're using for powering it and also for data transfer, and then you've got a high-rose connector. This has 4 wires on it, 2 for a low-frequency coil, 2 for a high-frequency coil. And then you've got a number of different human interfaces for it. You've got a push button, which gives you input to it, and 4 LEDs for taking output from it of different colors. So this tells you the status that the device is in while you're working with it. Some of the commands that are very helpful for this have been added recently, like the LF search and HF search. These give you opportunities for identifying a tag that you don't know what kind of tag it is. I've also got the commands here for reading in a waveform for a low frequency tag, reading NFC tags, the ISO 14A standard, and also some commands here for cracking the encryption on MyFair Classic cards. The USB stick that we're talking about here, this is one of many libNFC compatible USB sticks. It supports a wide range of NFC, and not a whole lot to say about that. Some commands here that you might find helpful for working with libNFC, for doing various emulation, reading tags, relay attacks, and also you can use libNFC to do more advanced functionality through scripting, of course, sending out NDAF messages if you want to do fuzz testing on Android. The RFiddler board, finally, on the RFID tools. This is a low frequency tool. You've got a lot of LEDs for output. A PIC32 is the heart of it. And then you've got two banks, or a bank of digital potentiometers, which you use for adjusting the thresholds on the reads. Here's some of the common commands that you would find on that. This is, of course, in the white paper as well. A latecomer to this project, though, was the Chameleon Mini. This is a platform for working with and emulating contactless smart cards. It was developed at the Ruhr University in Bochum and recently was started shipping from RISC Corp. But you can also grab the schematics and fab this board yourself. Looks like this. USB is for power and data, and then also you've got a reprogramming port with PDI headers, but you don't generally need to use that so often. On the embedded devices, the Raspberry Pi, I think everybody in this room is probably familiar with. The USB Armory is the little thumbstick, which also has an OTG host adapter. So you can use this to act as a client or a host in the USB mode. Now, the 3D printer that we had, the Cube Pro, this has got one of the larger build areas that I see in the consumer market, and it has the ability to go down to 70 micron layers and supports several different materials. When you're working with this printer, the first step is going to be you want to draw up your model in a CAD program, just like you would with any CNC or 3D printing process. But then, unlike maybe the MakerBot, for example, which many people are familiar with, on this one you're going to put down a coating of water-soluble glue. You then you put that into the printer, and you have an extruder that's going back and forth, depositing one layer of whatever thickness you wanted onto the board as the build plate moves down so that your project moves off from it. In the end, you can just pull it off with some hot water that dissolves the glue. There are some problems with 3D printing. You can't just draw anything you want and print it, and you do have to worry about machine maintenance. Up here on the screen, that's a picture of the extruder or the drive gears for the extruder on our Cube Pro. There's some debris in there. When you get debris in there, it can lead to clogs within the print jet, which are not fun. But RFID, that's what we're here to talk about. So to build a little basis of this, there's low frequency tags. These run around 125 kilohertz, primarily access controls, also PET tags, some vehicle immobilizer technologies I think work in this range. And then you've got the high frequency class. This is where NFC falls in. Access control, contactless payment cards, the German identification card, US passports, these all have high frequency tags in them. When you would open up one of these, what you're going to find is a coil of wires that is actually tuned to work and make an LC circuit or an LC tank with the little chip that you see in the top corner there. What this means is that when you put this into a field that it's tuned for, like the 125 kilohertz, it's going to draw some power up the chip, and the chip is going to be able to dampen, undampen, or kind of open and close the circuit so that the reader on the other side is going to be able to see modulations in the waveform. These are common modulations for many RF applications, not going to get into that. When you want to clone an RFID tag, you're going to work with the T55XX tags. These are, you can buy these over in the vendor area. I think you get 10 cards for $30, so they're not too expensive. You've got a support for a couple different modulation schemes, and then what you also have is reprogrammable EEPROMs. So you're able to throw on a configuration for this to tell it what type of data rate you want, what type of modulation scheme you want, and also how many blocks you're going to use for the demodulated buffer. If you want to work with one of these using the Proxmark to clone a tag that you don't know, you can start by doing the LF search command. It's going to read in samples and try and demodulate until it finds the tag. When it does find it, you'll see a report letting you know what the tag format is, the ID. You can see here we have an HID tag with dead beef on it. And then we can use this print demod buffer command, which was recently added in the past year to Proxmark. This will actually give you the bytes that the tag is sending out. You can break these down and split them up into the blocks that you need to put on the T55 tag. And then you still need, though, the block 0, the configuration block. So you could obtain this by going through the data sheets for your T55 card as well as the tag that you're working with, or you could try and decipher those values. But you generally don't need to do this because the Proxmark forums have lots of detailed information telling you the blocks that you need to set up for these. So you can see the configuration for the HID tag right there. And then now that we have that information, you just do a series of write commands and you've got a cloned tag. We can read it back in and we see that it is in fact cloned. So moving on quickly to the NFC end of things, one of the popular formats here is MyFair, which we're going to be working on today. These are tags that have some UID, 4 bytes or 7 bytes, and then some amount of data, possibly some security features. They get used in all sorts of places. Hotel key cards, which we'll look at cloning today, payment cards, lots of places. For cracking these cards, one of the earliest formats of them were MyFair Classic. And it was discovered that you could launch an attack whereby you power up the card and you could repeatedly get the same nonce and perform a cryptographic attack on it. Once you've recovered one of the keys, you could then launch a nested attack, and actually, in ideal circumstances, you can recover all of the keys for one of these cards, like what you might find on a train pass, in under a minute. And then you can use what are called magic cards, which are fully reprogrammable to write the data that you found and make, for all intents and purposes, a clone of that original card. This is really why you don't want to ever use an application like that lock sitting on the table over there that's only going to use a UID for validation. If you want to clone, for example, a MyFair Ultralight card, something that you might see in hotel key cards, for example, you can use libnfc. It's a very effective tool. Commands up here using NFC MF Ultralight. You can also, of course, scan a tag with your phone, and you have the bytes from it. You can then enter those bytes into a file, write that onto a tag that you want. I was using tags from clonemykey.com. So as I said, some of the things you can clone, you've got hotel cards. You've also got, as we learned this week at Black Hat, the possibility of being able to use some of these tools to clone transactions on EMV credit cards, because they have some legacy support in there. Also, Android Smart Unlock tags, and as I mentioned, the Samsung NFC locks. These are only validating the UID, so it's very easy to break those. You can see here what it looks like if we're using a cloned key card. It's unmarked, but clearly it opens the door. So now getting into the firmware hacking aspects of this project, one of the things that I wanted to do was work with both high frequency and low frequency, and I figured that one of the useful applications for me would be working with NFC tags in the standalone offline mode. So I went ahead and worked on writing code for capturing the tags and doing a clone to a magic card of the UID, also replaying of the UID. This can be extended fairly easily towards data sections on the card as well. So the initial low frequency mode of the Proxmark standalone, this is flowcharted out by the Proxbrute white paper. Basically, you hold down a button, flashes some lights, and then through either holding the button or pushing the button, you can manipulate whether you're in a playback mode or if you are in a clone mode, cloning to a T55 tag. Now, when you look through the source code, this is all in the white paper, of course, but you're going to find that everything runs on the ARM processor, of course, for this. There's a function, SAMI run, which makes use of various functions that are available to the ARM processor there for the HID functionality. When we want to go over to high frequency, however, I wanted to try and reproduce as much of that functionality as possible with the focus on MyFair cards. Not just MyFair Classic, of course, though. The ability to clone the UID onto MyFair Classic only was implemented, though. Here are some of the setup functions that you need for working with high-frequency tags, selecting them, getting yourself in reader mode, then for simulating. But the most interesting part of this, I think, was I decided to go ahead with a different workflow for how this was going to happen. In the low-frequency mode for Proxmark, for anybody who's used it, you might have noticed that you can jump right into the playback mode with uninitialized data. So you're dropping into the standalone mode, but then you have to hit a button again before you're going to get into read mode. I decided to get rid of that and instead jump right into the record mode. And then when you read a tag, jump into playback mode. Use this as the hopping point for your other functions through either a button press or a button hold. and also added in some sanity checks so you would never use an uninitialized value, and you also wouldn't inadvertently fill your banks with the same card. I do have a demo here of this, but I'm going to hold off on doing that because I have a lot of slides and not as much time. So if there's time at the end, I'll come back to that. Otherwise, if anybody would like to see this, you can hit me up, Twitter, or tap me on the shoulder, whatever it might be. So the second component of my firmware hacking, I wanted to add support for a tag format that wasn't in Proxmark. I wanted to learn how to do that and be able to document this with really a tutorial-like example so that other people would be able to go back and add support for other tag formats that they might be interested in. So in order to do this, I decided I would make the LF AWID context for Proxmark. This means cloning most of the functionality that you would have in the HID mode. Writing things to T55 tags based on the numbers printed on the tag, because if you see here on the printout of that tag, it's actually screen printed with all the information that you need for being able to clone it or simulate it. Whereas most tags, you're going to have an ID number, but it's not going to disclose all of the information that you need, like the facility code and the card number, rather. So since there was no support in this when I started looking, I decided it would be a great place to work on. So the AWID 26-bit format, that's what I specifically targeted. This is comprised of an 8-bit facility code and a 16-bit card number. Now, that's only 24 bits, but then the other 2 bits come from parity. And the card is going to work with the same parameters actually as an HID tag. It's got this FSK2A, which means RF50 data rate, and it's specifying a certain number of cycles that you're going to go through with the higher frequency to indicate a logical low versus a logical high. And then when we want to start adding the commands into the Proxmark, you have to understand that there is a command table structure. Things are hierarchical, so you just need to add a definition in your new file that you're creating, and then within the functionality that's actually going to be called, you're creating a USB command structure and sending that off to the FPGA. So you can see here how it looks. This code is all, by the way, in GitHub already in the master branch for Proxmark. You can see here the FSK DMod functionality, and up on the slide here are some of the functions that you need for working with that. In order to move beyond this into the clone and simulate functions, I needed to develop a function to take those numbers printed on the card and convert that into the Wigand. For this, I decided it should stay within the ARM, or within the client code. It doesn't make sense to have this down on the ARM chip, where it's going to take up space, and the ARM is never going to know anything about these numbers anyway. So I was then able to go right ahead into doing the LF AWID clone functionality, which is piggybacking on the T55XX commands under the covers, and also showing to you, as you see, the blocks that it's calculated that you need to program onto the card. The simulate function also has no purpose within the ARM, so this lives in the client code, and you can see up here the parameters that you need to specify in the commands. There's a lot more detail about that in the white paper. But now the antenna construction. This is where we get into 3D printing and the applications there. So when I started, I was always interested in making an antenna for my Proxmark and for other tools, but I noticed that the DIY projects out there, they felt a little bit too artsy craftsy for me, maybe. There's a bit of trial and error going on there. So I thought I might be able to do better with making 3D printed forms for that. And that's what I did exactly. So to make a coil for the Proxmark, you take some wire, very thin, thinner than a strand of your hair, like 40 gauge wire, and you want to coil that around a form to make your coil, or wind it around a coil. So you've got some functions that you can find for going between the function, or the frequency, and the inductance that you need based on the capacitance in your circuit. You've also got some functions from, or some equations from white papers out there explaining the relationship between the number of turns and the dimensions of your form to the inductance. With all of that, I went and looked, and I saw that there was a nice design for an LF badge on the Proxmark website, but it was using cutting out CD cases, gluing them together, stuff that I didn't really want to go through. So I took that design and I basically just drew it in some CAD software, printed it out, and I found that it worked really quite well. In the end, it took around 87 turns for the Proxmark and about 57 turns for the RFID. But you would find if you wanted to reproduce that, it's going to vary a little bit due to the nature of the system. But all those equations, fortunately, don't really matter all that much. As long as you've got enough turns, you plug it in, you try and tune your thing, so you see what frequency it's optimal at, what voltages you're getting out of it, and then you simply unwind it one by one until you get to the frequency that you want. So you can see here the antenna that came out from this, I tuned it exactly for 125 kilohertz, and it actually worked better than the commercial antenna that I had already paid $60 for. So whereas that antenna was picking up at its optimal voltage 29.43, I was getting 31.21. I know you can get a lot higher than that even, but this badge worked very effectively or this card worked very effectively for me. So I then went ahead and added a lanyard clip to it, and made something that looks like this. This actually broke on me. Word to the wise that that 40 gauge wire, very, very thin. You want to do everything you can to reinforce that. Hot glue, higher gauge wire, these are your friends in this. But in the end, this was a very inexpensive build. Even going out through Shapeways, you can use the model that's on GitHub now and have this printed for $7.68 before your shipping and handling. With the Cube Pro printer, it costs maybe $4 to print out the form for it. And if you actually had like a MakerBot that you can feed in generic filament to, you can do this for well under $1. And then I cut up a lanyard and an RCA cable and made it so that I could have the cable going down through my shirt into the Proxmark in my pocket out of sight, and just kind of looking like an actual badge with a sticker with my picture on it. The next project that I looked at here was the clip pwned. So a lot of people talk about using clipboards in pen testing situations for RFID. So I decided to see what I could do with the fact that I now have 3D printable antennas that could be kind of fit into my thing. And you can see just by printing out some simple shapes, you're able to make nice spacers to have a very clean, covert little board. You can hide this with some papers inside there in case somebody opens it up, it won't look so suspicious. And in general, if you want to make one of these, there are all sorts of storage clipboards out there on Amazon. You just need to make sure that you find something that has enough depth to fit whatever it is that you're trying to hide in there. So you can also enhance this if you wanted to by adding in something like the USB Armory or an RFID board, a Raspberry Pi board. And if, say, you had an RFID in there, all you need to do is connect something that's going to be listening with USB serial and logging that data very simply. And you can walk around all day and then come back and have a log of all the UIDs you've captured. With the Proxmark, you can, of course, take the client code and you can build this. It's already got an ARM build for Android, so that shouldn't be too much work. And then you can also move on to making fake readers and doing other things to hide your tools in the field. So one of the valuable resources for this, you have building information models out there. So if you have AutoCAD, they have their Seek environment, which allows you to search for lots of things that you would find in different buildings. I found, for example, this HID reader enclosure, which if my 3D printer hadn't failed on me, I would have printed out to bring here. But you could very easily hide inside of that a custom circuit board or a tool with an antenna, and maybe put it in an unexpected place, maybe conceal a legitimate reader, and use that to try and capture badge swipes. So really what we're looking at here is the fact that you can make realistic prints of things, and you've got models out there. But even if you don't, you can use something like a Kinect or even an Android phone or an iPhone with the 123D Sketch app and actually just take pictures and get a very reliable 3D form out of this. The next thing that I was looking at was using a phone case to actually hide an antenna inside of that. And some of the things that I would envision doing with this, you could, of course, do exploits on the Android Beam type functionality. Say somebody thinks it's just a phone, but really you've got some more sophisticated hardware on there. But also the initial intent that I had for this was being able to eavesdrop on the NFC communications for something like Apple Pay or Google Wallet. And there are so many phone cases out there that it really should be trivial to just take one of those and actually merge it with the design for a coil in such a way that it's not going to be obvious. On the embedded side of things, some of the other things that I was looking at were adding in the support for the USB Armory to be able to log keys, doing scriptable responses, and also being able to do something like if you use the OTG adapter on here with a little passive USB hub, you could have a Wi-Fi adapter in there and actually have a two-man team where one person is going to be using the device but not being able to see it, not knowing when it's read something, but somebody else, maybe a couple hundred feet away, is going to be able to access it, monitor what's being scanned, trip it into simulate mode whenever it needs to be. So there are a lot of possibilities with that for pen testing. And actually at this point, I do have some time that I can try and do the demo of how the standalone mode works for NFC. So I'm going to take the Proxmark out of the clipboard and plug it into a little battery here. And I need my high frequency antenna for this, just right here. So now power that on, also add the extra battery back into this. So it's let us know it's happy. And we gotta lock it. Oh, it's not so happy. Try that again. It thinks it's locked. It's not the smartest smart lock. All right, so now it is in its locked mode, and if I take this card, we can see this one does not open it. This one, however, will open it. Then we'll relock it. This, however, is a magic tag. So if I now power up the Proxmark by holding on this button, it flashes its lights for me, which I'm sure nobody in this room can see. But I can then go to the tag that works for it. When I touch it down, it is lighting up to let me know that it has scanned in a tag. Now it's in playback mode. Now, one of the problems with playback mode, either the shape of the antenna or possibly the implementation of NFC on here isn't always so conducive for this. So what we're going to do is try it out, but this did work once earlier today, but yeah, generally that's not happening, so we're going to clone it to a tag by holding down the button now, putting it on the field of the tag, and then when I release it, it flashes to let me know it's written it. And with any luck now, we can go ahead and, oop, maybe not. Let's try that again. Oh, my antenna was loose. The high-rose connector on this is not always so great for holding in cables. So let's just put it in standalone mode again. Go ahead and scan in this tag. And then we will clone it onto this one. Hopefully it hasn't been bricked. One of the risks with working with the Magic cards is that if you don't have a strong connection to the antenna while you're writing to it, you can actually break it, which is why I stuck to just MyFair Classic, where the tags are cheaper. But now we do have it working. So that's pretty much what I've got for you. If anybody wants to see any of this stuff up close, you can definitely come up here, or actually meet me outside afterwards. And Just I want to say thanks for the Proxmark development team, Marshmallow and Iceman. Very, very great for being helpful with working with this stuff, being very patient. And also to my family for putting up with all the crazy hours leading up to DEF CON. So, yeah, thank you. Oh, and I guess there are a few minutes for questions if anybody has questions now.